Hey everyone, today we're going to look at law of sines, and in the following video we're going to look at law of cosines, which will be the final two theories for this class. Before we go into law of sines though, let's look at how do we solve oblique triangles, right? So what is an oblique triangle? So an oblique triangle is a triangle that has no right angles. So essentially it means it's either an acute triangle, right, where all angles are acute, or it could be an obtuse triangle where one angle is greater than 90 degrees, right? Now, to solve any triangle, when I say solve a triangle, what it means is it means that you're trying to find all the sides and all the angles. Okay, so if I want to solve any triangle, I need to be given some information. All right, so particularly if you remember from your geometry class, we could be given the following piece of information. One is you have ASA, which is angle, side, angle. All right. Then we have SSA, which is side, side, angle. Okay. So the difference, and then we have SAS, which is side, angle, side. So the difference here between SSA and SAS is for SSA, right, I'm given two sides, any two sides, okay, and I'm given an angle. And notice that this angle is not included in the sides, right? So this angle is not the angle that is formed by the two sides, it's any of the other angles. Whereas in SAS, this angle A is the included angle. So for SAS, this would become side, angle, and side. So that would be the included angle. Okay, so that's how those two are different. Now, another way we can solve is I'm given the information on three sides. So side, side, side. Okay, so these are the four different pieces of information. If I'm given any of these three, right, so side, angle, side, side, angle, side, angle, side, angle, side, angle, or side, side. If I'm given this piece of information on a triangle, any one of these three, right, I can figure out the rest of the measurements of the triangle. Okay, so for example, if I'm given one angle and two sides, I can figure out what the third side is, and I can figure out what the remaining two angles are. Okay, the one thing that doesn't work is this: angle, angle, and angle. Right? This will not help me solving a triangle, because think about it. I could have a 60-degree, right? I could have an equilateral triangle where all angles are 60 degrees, right? And all my sides, let's say, are of length 1. But I could have a same triangle, just a bigger one, where all angles are 60 degrees, but all my side lengths are, say, 3. Okay, and obviously I get two different triangles. So I cannot solve a triangle if I'm given all three angles. But if I'm given any of these, I can solve a triangle. So what we're going to do today is we're going to go ahead and look at how do we solve a triangle if I'm given these two. Okay, so if I'm given SSA and ASA, in this case, I use what we call the law of sines. All right, and then if I'm given these two, we use what we call the law of cosines. Okay, so let's go ahead and see what the law of sines is. So here's my triangle, right? I have an oblique triangle with angles A, B, and C, and these are my sides A, B, and C, and H here is the height of the triangle. Okay, now if you look at this triangle, let's call this point X. Okay, if you look at triangle CXB, okay, what is the relationship between angle B and H? I know that sine of B is going to be equal to the opposite over the hypotenuse, and here the side A is going to be my hypotenuse for that triangle. So sine B equals opposite, which is h over A. Okay. Now obviously A is a non-zero number, right? It's a positive number because that's the length. And so I'm going to multiply both sides by A, and I get h equals A sine B. Okay. Now similarly, let's take a look at triangle CXA, right? So triangle CXA. If I look at angle A and the side H, they're related by sine of A equals opposite over hypotenuse, right? So here my hypotenuse is B, so I have sine of A equals H over B, which is the opposite over hypotenuse. And if I cross multiply again, I'm going to get H equals B sine A. Now, these H's here refer to the same height, so obviously this A sine B has to be equal to B sine A, right? Because they both represent H. And so I get A sine B equals B sine A. Okay. So divide both sides by AB, right? If I divide both sides by AB, I get sine B over B equals sine A over A, right? So the law of cosine states that, law of sines states that for a triangle ABC, okay, with sides A, B, and C, we have sine A over A equals sine B over B equals sine of C over C. Okay, or we could also write this as, sometimes you might also see it as A over sine A equals B over sine B equals C over sine C. Okay, so this is what we call the law of sines.